In this video, I will learn to make the equivalent static earthquake load analysis using Staad. First of all, we have to create a structure, frame model, three-dimensional frame model. I will create basic. Let's double click on this. I want 3 bay along each direction. Let's say 5 meters, and let's make 3 meters. No, 2, 6. Let's say this is 8, and number of bays in each direction 2, and 2-story height. 3 meters is the story height, so 6 meters is written here. 3, height 3, and 4. Okay, let's continue. What we do is, after creating the model structure, let's create and assign the support. Okay. Let's assign fixed support to support. Assign to the selected nodes. Okay. Let's create and assign the property, member property. Let's define a property. And to make it easy, as a result, for beam and columns, I will use this section, circular cross section, 0.5 meter diameter. Add, close, and assign it to the view. Now our intention is here to learn how the equivalent earthquake load is applied. You know, equivalent load earthquake load is, we calculate the base shear applied to the structure, and then distribute it to the stories using some formulas. It's the static load. Staad make this normally according to the standard we used as a reference. We calculate these static loads and apply them to the stories. If there is an eccentricity in the plan, generally standards tells us using 5% eccentricity. As a result, in addition to the story forces, some in plan acting, in floor plan acting story moments are applied to the stories. I mean, stories. Stories may be assumed as rigid floor or not, depending on its situation. This is not the subject now, don't make it complicated. But here Staad, using the tools in the Staad, we do not need to calculate the magnitude of these forces, and if there is eccentricity and also the moments, apply it or distribute it to the stories of the structure. We give some information, enter some information into the program. The program makes the calculation. Now we have X and Z direction. In X and Z direction, we will calculate the equivalent earthquake load, static load, and the program will make it so as the structure is now ready. We have to define only the support, no specification I will define here, load and definition. Now to apply equivalent earthquake load, we have to first make some definitions, seismic definitions. Seismic definitions include the soil information about our structure and some lateral earthquake acceleration data, and depending on the soil type, some amplification for the earthquake acceleration, lateral earthquake acceleration are also calculated. Those things are done according to the definitions we enter to here. Now let's click Add to make an explanation. Now the seismic definitions and seismic parameters differ according to the country standard, or according to the standard we use. Chinese, Colombian, American, Algerian, Canadian use always different. Turkish use different standards. Now I prefer using International Building Code, and it has 2001 version, 2003 version, and 2006-9 that version, 2012 that version. According to the owner of the job, I know, you know, the structure which will be done has an owner. He pays the money and wants from you to make the analysis, and then he will want someone else to construct the structure. And he also wants that you use in your country. For example, you're in America and you have to use, he stipulates that you will use International Building Code and this version. So select it. Here you see parameters change according to the standard you choose. You see different parameters as you see here. As if you choose, for example, International Building Code, you see here there are some values which has to be entered to the program. Zip code, the postal code, in which or the place in which your structure will be constructed shall be entered here. Provide the zip code of the location of the site, structure site, to automatically sort the latitude and longitude and consecutively to calculate SS and S1 factors. That means enter here zip code, and those values highlighted with yellow or which has a background of yellow will be calculated by the program. Okay. Provides latitude and longitude instead of zip code if not known to calculate SS and S1 factors automatically. Means that instead of entering zip code here, you can manually enter the latitude and longitude of your site in which or at which your structure will be constructed. Manually you can enter it here. SS is a SS and S1 are some coefficients, some values taken from elastic design spectrum. Elastic earthquake acceleration design spectrum. It can be obtained manually from different resources, and can be also entered here. The explanation of SS and S1 was this is short period acceleration. This is the 1 second period acceleration, as far as I know, I remember, but I may remember wrong. Long period transition period. This is 12 seconds according to this standard. For example, in Turkish standards, it's 6 seconds, as I remember. Importance factor depends on your the importance of your structure. For example, if it's a school, it will have a higher value. If it's a normal resident, it will have general 1. Response modification factor. The definition of those terms are explained in the standard. You have to read the standard to change the values of those factors. You have to understand what those things are. For example, for Turkish standard, I know the values of those parameters. I know the value of A0. I know the value of TA and TB. I know from where I can get this. In Turkish, there is a website. You enter the latitude and the longitude of your structure and select its ground type, and all those values are given to you, and from tables you can obtain all those values. This coefficient is used to reduce the earthquake acceleration. Okay, earthquake acceleration is taken from the lateral earthquake acceleration design spectrum and divided by r. This is r might be different for x and z direction. And this is a value to calculate also to be used in an empirical formula. I guess I know also what it is. These are the periods which can be obtained by means of model analysis. I think model, but which can be obtained by model analysis, which is performed by a software like Staad Pro. Separately, you have to make a model analysis before doing this analysis, which is the state equivalent stating earthquake load analysis. Something like that. But you know, they differ. Now it's not important. So now let's use that one and assume that the zip code, my structure will be built here. So those parameters are automatically calculated, and other parameters have those default values, and I accept them. Explanation of those parameters are given here. Period in x direction, period in z direction shall be provided. And there is star here. I don't know, without entering any value for them, it is, I think, impossible. You have to give some values to them. CT value, optional CT value to be used in calculating period of the structure based on empirical method. Let's give one value here. Let's say 1 period. Let's say 0.5 seconds. 0.5 seconds in each direction. What is x? There is no star here. There is no explanation given here. I think star means the value of those coefficients or parameters shall be entered. Okay, this is the guide. Just read this standard and understand what are those quantities and calculate their values and enter here manually if they are required. So seismic parameters. So seismic definition. One seismic definition is defined. A second seismic definition is not possible, and I think it can't be changed later. Self-weight. Under seismic definition, we enter the values of those seismic parameters, and in addition, we have to here show the mass of the structure in terms of weight. Our structure is composed of members. These are beam members, column and beam members. In Staad Pro, beams and columns, all of them are called as beam. So self-weight at the self-weight. Self-weight will be taken into account because to make any calculation, the structure has to have weight. What actually means the structure has to have mass. But not only the members have weight, but also we have floors. I didn't build or formed, created the floors here, but they have weights. So this is a structure. So floor weight, I have to enter the values of those things. For example, floor weights are composed of permanent or sustained weights. Those weights include the dead load of the floor concrete, and also if there are some permanent live load portions, which are the sustained loads, they shall be added to this floor concrete. Let's say now I will show you how the lateral earthquake equivalent, static equivalent lateral earthquake load is applied by means of Staad. So their weight is given here as 5 kilonewton. I assume this value, and I assume this value is valid not only for first floor but also for the second floor, and my story height is 6 meters. So on both floors, assume this 5 kilonewton per square meter floor load, which is the floor mass, and take it into consideration in the analysis. Click on it. So seismic definition is completed. So let's come to load case details. Now, which loads do I have? First of all, I have to define the load. I will define a seismic load, earthquake static seismic load, act in the x direction and in z direction. Actually, I can define this load only in x direction or only in z direction. And if my structure was symmetric, I prefer to do it so. But since the span in this direction in x and in z directions are different, I want to create seismic load. It's a seismic load. Lateral equivalent static load is also a seismic load in both directions. This load will be equivalent static load in x direction. In x direction. Okay. And in the other direction, I want to create another seismic load. Okay. And I want to create also the real dead load of the whole structure. And then if I have live load, I want to create it also. But now I want to skip the live load. That's it. Let's say close. Now let's create this load. under seismic load, in x direction this will be, factor is 1. If you want to consider also the 5%, generally it is 5%, as I stated, eccentricity or the equivalent static load, click here. We have no rigid diaphragms defined. Add. Close. Finished. In z direction, add seismic load. In z direction. Consider 5% eccentricity. Add. Close. Add. Depth load. Self-weight of the members. Add. And floor load, because of the floor concrete. It's 6 meters story height. The pressure in the global wider, let's say also -5, but it was -5. Add. Close. Here I will add another load case. Actually, it is combination load. We can create combination by means of this command, or we can make some different thing. Now add, it's a primary load, it's a combination. Now I am using another method to create a load combination. Let's say none, and let's say this one, earthquake load in its direction plus that load. Let's say at another one, let's say earthquake load in z direction plus that load. Click on close. Click here add. Now I will make it composed of, I will create a combination. Earthquake load in its direction and that load in its direction. As you see, their factors are assumed as 1. So it's service limit analysis like click add. In z direction and that load again, click add. Okay. Now they have no difference than load combinations, but this is another way of creating load combination. So I have finished creating every load. So what's left behind? Analysis. Print analysis. Code is written here, and let's run the analysis. No error, one warning. View output file. I always encounter with this message. Please note that depending on the shape of the floor, you may have to break up the floor one-way load into multiple commands. We don't have floor one-way load actually. I am happy with the command I applied. That's okay. And then all loads are selected, and just select the load. That's, for example, let's see the load. Deflection is open here. Click here. Press on the control button and play with the scroll button. Now we don't see the static load acting in direction X, but as you see, it's acting because our structure displaces in the X direction. Now select the load in the Z direction. As you see, our structure displaces in the Z direction. Now select that load. As you see, this is the displacement which can happen only under that load. And now the third load is here. Now the displacement because of combination, as you see, it's so. As I see, the effect of that load is dominant in comparison to the earthquake load. Okay, click on here, play with scroll button. That's okay. And you can obtain the reactions value. You can play, and you can obtain the value of this nodal displacements. Member forces you can obtain graphically or manually. Since this is a three-dimensional structure, you can obtain bending Z moment, bending Y moment. Let's obtain this under that load. Can obtain bending moments. If we have torsion, you can see that. If we have shear force, normal force, you can visually by your eyes see the diagrams, or you can obtain reports, and in the reports you can obtain the values of internal forces, reaction forces, or you can click on any member and obtain the values of internal forces depending on the load or load combination. So this video has finished.